Good morning, everyone. Today we will continue our lesson, Thin Lenses. Already we talked about the first 5 cases. Today we will talk about the last one, which is the most important one, when our object is inside the focal length. So I will remind you about the previous cases. The first one, we said when the object is very far, the image will be created where? At f, at the focal point. The second one, we said if the object is beyond 2f, the image will be real and inverted. Where is it created? It's created on the side where we have the refracted rays, back of the lens. Okay, when we bring our object closer, when our object is at 2f, the image created will be also at 2f. We said it's the same size of the object and it's also real and inverted. And when we bring our object closer more, between 2f and f, we notice that our image gets bigger, okay, in size, but it is still what? It is still real and inverted. What mean real image? What means? It means for sure that this image is created by the intersection of the actual path of light, and it's projected on a screen. Now, when we bring our object closer more to the lens, like for example here our object is at the focal length. Here we said the image is at infinity because the rays we get, they are parallel to each other. So we cannot find the intersection point. It's very far, the image, it's at infinity. Now this is the very important case where the object is very close to the magnifying glass or to the converging lens. We will follow for sure, girls, the rules I told you about. The first rule, we said if ray number 1, we said ray number 1 when we bring all the rays from the tip of the object, right? The ray number 1 when the object is parallel to the principal axis. How will it how will it refract? It will refract by passing through the focal point on the other side. This is the first ray. The second ray, we said it is the opposite of the first. Okay, this is the tip of the object, so I will bring from it the ray, second ray. Girls, always revise the rays in your mind before you draw on your paper. The second ray is the ray passes through the focal point and leave parallel, right? Okay, where is the focal point here? The focal point here is behind our object. So for sure this ray cannot pass through it in this side, the front side of the lens, the side where our object is. So as with mirrors in the previous chapter, we will direct this ray, we will bring it to the lens as if it's coming from the focal point. So we just care, girls, about the lens that is directed toward the lens. So how will we take it? We will take it just as if it's coming from this point, because we know that any ray that comes or passes through f, it will leave the lens how? Parallel. Okay, so this is the trick here. Ray number 2, okay, because the focal point here is behind the object, so the ray will be directed toward the lens as if it's coming from the focal point. Okay, so this ray, how will it leave the lens? It will leave parallel. So this is the second refracted ray. Okay, this is the first refracted or emergent ray that leaves the lens. This is the second refracted ray. The third, what is the third? We said, girls, any ray that passes through the center of the lens, the optical center, it will continue without any refraction. So this is the easiest ray, I think. This is the third refracted ray. So girls, here when you compare these rays together, you can notice that they can't meet, these rays, even if you extend them. So they are not able to meet. So what to do in this case? In this case, we extend them backwards. See the dashed line here, it represents the apparent path of these rays. So these are the actual rays, the actual refracted rays. Okay, These are the real refracted rays that leave the lens. But these rays, they will not meet here anywhere. So when we extend them backward, this dashed line represents their apparent path. When we extend them backward, they meet at a point here. So this point here is the intersection point, but as you can see, it's the intersection point of the apparent path of light, not the real path. Therefore, this is the intersection point, and here we complete our image, and this image is what is virtual, because the virtual image is the image produced by the intersection of the apparent path of light, not the actual path. A very common application about this one is the magnifying glass. The magnifying glass, girls, why do we use it? You know that we use it for sure, girls, in order to make, for example, words bigger, right? Okay. So the magnifying glass is used to make words bigger. We put it over the words or any paper or any book, and we look through it, right or no? So your eyes here on this side, and you look through it, and this is, for example, the small word. It works as the object, our object now. So the words now are our object, and we see, girls, we see the bigger words in the same side of the object. Okay, we see them like farther a little and bigger in size. Okay, so for sure, maybe all of you have the magnifying glass. You can try it. You can just hold the magnifying glass over a piece of paper with some words, okay, and you can see the words how they look bigger when you look through it, and they look like farther from the lens as than the object. Okay, so small objects placed very close to converging lens, the image of object is highly magnified, and it's on the same side as the object, for sure. Okay, so the observer always here looking from this side. The magnifying glass, so it has more than one use. We can use it to burn a hole, as I showed you like earlier in the first case, because I told you the sun is very far, so the rays coming from it are nearly parallel to each other. So when they pass through the magnifying glass, they converge, they bend inward to focus on a point, so they burn a hole. I can use the magnifying glass in another way, to enlarge words, to make them bigger, and this will be like the last case we talked about, case number 6. Okay.